Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the solubility constant, KSP, and relative solubility. So generally speaking, we cannot use KSP values of different compounds to compare directly their relative solubilities. And here's an example to show why you can't do that. So here we have a compound, magnesium hydroxide, and we have iron carbonate. So iron 2 carbonate and magnesium hydroxide are being compared, and here we have their KSP values. So you can see that the KSP value for magnesium hydroxide is 2.06 times 10 to the negative 13, and iron 2 carbonate has a KSP value of 3.07 times 10 to the negative 11. And you can see that the KSP value for iron 2 carbonate is higher than that of magnesium hydroxide. So this negative 11, remember that negative 11 means you have a larger value. So if this is less negative, then this value is larger than this value because that is more negative. So this is a smaller number than this one. However, if you look at the solubility, this solubility of iron 2 carbonate is smaller than that of the solubility of magnesium hydroxide. So you can see here that this is a less negative number than this one. And so you can see that, okay, well, even though the KSP value for iron 2 carbonate is larger, the solubility is smaller. And the reason for that is because we have to take in consideration the dissociation reaction. What's the stoichiometry of the dissociation reaction? Here you can see that when I dissolve this in water, I end up getting a magnesium ion and 2 hydroxide ions. So I get 3 ions dissolving in solution. Here I only get 2 ions. So that's going to influence the solubility. So when we're trying to compare directly, then we need to compare to make a direct comparison of the KSP values, right? We need the same dissociation stoichiometry for each of the substances we are looking at, right? So here's another example of a table where instead of iron 2 carbonate, I'm comparing magnesium hydroxide to calcium fluoride. And so you can see that here, both substances, when I dissolve them, these are going to dissociate into 3 ions. So both of them dissociate into 3 ions. And so now you can see that here, when you're comparing the equilibrium constant or the solubility product constant here, so magnesium hydroxide again has 2.06 times 10 to the negative 13. And here calcium fluoride has 1.46 times 10 to the negative 10. So you can see here that the KSP for calcium fluoride is larger than that of your magnesium hydroxide. And if we look at the solubilities, we can also see that the solubility of your calcium fluoride is also larger than that of your magnesium hydroxide. So you can compare magnesium hydroxide and calcium fluoride directly according to their KSP. So I can determine from their KSPs alone which one of these is more soluble in water because they have the same stoichiometry, the dissociation stoichiometry. So keep that in mind when you're using KSPs to determine which substance is more soluble or less soluble in a given liquid. So I hope this is helpful. I hope this clarified a few things for you regarding KSP and relative solubility. Thanks for joining me. If you like my video, please make sure you hit this like button right there before you leave, and also subscribe to the channel. Make sure that you also hit that notification bell up there so you can be notified by other videos I put out. And lastly, make sure you put a comment in the comment section. Let me know what you think. If you have any questions, please ask. I love to answer questions. Thanks for joining me and have a great day.